All right, everybody, welcome back. So I've improved some of the graphics over here. So hopefully the video is going to come out a little bit better this time around. So let's go ahead and look at some more examples of rational functions. Specifically, we're going to look at graphs. So right now in example 1, we have a graph of a rational function with 2 branches. So let's go ahead and highlight those branches. So as you guys can see, here's the first branch over here, and then the second one over here, right? So these are 2 branches, and then something else that you notice is you have dotted lines, and the dotted lines in this case tell us where the asymptotes are. Now keep in mind that not every graph is going to show you the asymptotes with a dotted line. In this particular case, it just so happens that the dotted line, the asymptotes are shown to us. So you can see there's a vertical asymptote over here, and it looks like the vertical asymptote is at x equals to 8, and then there is a horizontal asymptote over here. And we're going to talk about that in a little bit. So I just wanted to point that out before we start answering the question. So let's go ahead and answer some questions. So, oops, let's see. So for part A, there you go. For part A, let's go ahead and identify any vertical asymptotes. If any exist. So as we mentioned, we can see that there is a vertical asymptote over here as a dotted line, right? So here it is over here. But if we didn't have the dotted line to show us that, then the way that we would be able to tell that we have a vertical asymptote is by noticing the behavior of the function. For example, you're noticing that this branch is trying to get as close as possible to that line, and then this branch is going down and is trying to reach that line over there as well. So you can still tell by the behavior of the function, even if you don't have a dotted line to give you that information. So it looks like our vertical asymptote, let me highlight it one more time, is right here, and it's located at x equals to 8. Remember, every single vertical asymptote is a vertical line, and the equation of every single vertical line is x equals to some number. So let's go ahead and write it down. So we have one vertical asymptote. It is at x equals to 8 in this case. Again, it's right here where x equals to 8, and the entire equation of the line of a vertical asymptote is x equals to something. In this case, x equals to 8. Let's go ahead also and find some horizontal asymptotes if they exist. So identify horizontal asymptotes if any exist. So again, let's go ahead and pay attention to the horizontal asymptote. It looks like we have one right. So we have a horizontal asymptote. Let's see, this looks to be 2, 4, 6. So it's in the middle between 0 and 2. So it looks like there's a horizontal asymptote at -1. Now remember, every single horizontal asymptote is a horizontal line. And the equation of every single horizontal line is y equals to some number. In this case, because the horizontal asymptote is at -1, our horizontal asymptote is y equals to -1. Okay, let's go ahead and answer a third question. For example, something like this. What if we're asked to find, for example, f of 6. Now let's remember what this means first. What does this mean? So f of 6 means what? X is 6, so I need to find f of 6, meaning y. Or in other words, when x equals to 6, find what the function value is there, right? So in this particular case then, so if we're looking for f of 6, then we're looking at the graph for where x equals to 6 right here. So x equals to 6 right there. So what is the y value right there at x equals to 6? It looks like the graph is actually intersecting the x-axis. So the y value there is 0. So then f of 6 then equals to 0. This is also an intercept because anytime either x or y coordinate is 0, you have an intercept. This is also an x-intercept because y happens to be 0. All right, let's go ahead and look at another graph. Let me bring another graph over. So let's insert a second graph. There you go. All right, so this is going to be our second example. All right, so let's go ahead and ask the same question. So we want to find any vertical asymptotes, if any. We want to find any horizontal asymptotes, if any. And then let's also answer something like this. What is, so find f of, for example, 0. All right, so let's go ahead and answer these questions. So we're going to look for vertical asymptotes first. So again, we have the help of some dotted lines over here. So as you're noticing, we've got our first vertical asymptote over here, and it looks to be, let's see, if this is -4, that means it's -2, -4, -6, -8. So there seems to be a vertical asymptote at x equals to -6. And then there's a second vertical asymptote right here. So this is 2, 4, 6, 8. So it looks like it's at x equals to 6, right? Again, if you didn't have the dotted lines, you would look at the behavior of the branches of the rational function. They seem to want to get as close as possible to this line, but never cross or touch it. So these would be our vertical asymptotes. So we said the vertical asymptotes were at, where did my blue pen disappear? There it is. So we have a vertical asymptote, 2 of them, right? We said we had one at -6 and one at 6. All right. Now let's go ahead and search for some horizontal asymptotes. Now notice we don't have any dotted lines for horizontal asymptotes, but we actually still have one. So how do I tell if I have one or not if I don't have a dotted line? Pay attention to the behavior of your function when it approaches any horizontal line. So for example, if you're noticing this branch over here, it's trying to get as close as possible, but not quite crossing or touching this line over here. Now, what happens with this branch? This branch is getting as close as possible to 0, right? But then it crosses it and then it goes down. So in this case, it crosses it. And then what about this branch? This branch is trying to get as close as possible again to 0, but not quite touching or crossing it. So then what's going on? It looks like we have a horizontal asymptote at y equals to 0, but we do cross it over here. Well, remember, vertical asymptotes are very strict. We cannot cross or touch vertical asymptotes. However, horizontal asymptotes, it is possible to cross them, which is the case that you see right here in the middle. Right? This is the case that you see here in the middle, where the middle branch of the rational function actually crosses that horizontal asymptote. So let's go ahead and write that horizontal asymptote. We have the horizontal asymptote at y equals to 0. Finally, we want to find f of 0. This means what? When x equals to 0, find y, right? So let's go ahead and figure that out. So when we're asked to find f of 0. So when x equals to 0, where is x equals to 0? Right here at the origin. And it looks like the graph exactly passes through that point. So when x equals to 0, the corresponding y-coordinate on this function's graph is also 0. So then the answer is f of 0 is 0. Again, this is also an intercept, right? It's both an x-intercept and a y-intercept. All right, let's go ahead and look at the third example of a graph. Okay, let me move it. Okay, so this is going to be our third example. All right, so let's go ahead and ask a very similar question. So we want to find any vertical asymptotes, if any. We want to find horizontal asymptotes, if any. And let's see, we're going to ask also, what is f of 0? So we want to, let me rewrite that. Let me rewrite it as find f of 0. There you go. Okay, so let's go ahead and look at this one. So notice there are no dotted lines at all in this case. So we're going to have to figure out on our own where the asymptotes are. So again, we pay attention to the behavior of the branches. So we have two branches of the graph. So let's go ahead and first try to identify any vertical asymptotes. So what are you noticing? Vertically, what's going on? This branch is trying to get as close as possible, right, to the y-axis. This branch is trying to do exactly the same. So both of these branches are trying to get as close as possible, but not crossing or touching the y-axis. Well, so it looks like we do have a vertical asymptote, which is exactly the y-axis. Now at the y-axis, that's where x equals to 0. So that means we have a vertical asymptote at x equals to 0. So let's go ahead and write that down. Okay, now what about horizontal asymptotes? Now we're going to do the same thing, but we're going to pay attention to what the graph is doing horizontally. So again, you're paying attention to the first branch. It's trying to get as close as possible, right, to the x-axis where y is 0. What about the second branch? Again, it's trying to get as close as possible to the x-axis, again, where y equals to 0. So we do have a horizontal asymptote as well, and that one is at y equals to 0. All right, we would like to also find f of 0. So remember, this means what? This means when x equals to 0, find the y value. So where is x equal to 0? Right here. Well, we already kind of know the answer, because if I'm looking at x equals to 0, there is no graph there because there is a what there? There happens to be a a vertical asymptote there. So the function is not defined at x equals to 0. There is no graph that's ever going to touch or cross that y-axis. So then if I'm writing f of 0, when x equals to 0, the function is undefined because there is no y coordinate corresponding to when x equals to 0.